Distinguished audience, ladies and gentlemen, good afternoon. It's a big honor for me to give this presentation, and I want to first thank the organizers for this invitation. I'm now talking about sustainable research strategies for smart production technologies. And I would like to start with the conclusion. Our research strategies have been changed completely. We are now following a holistic approach consisting of fundamental research, applied research, innovation creation, industrial implementation and standardization, and last not least, societal acceptance. With this background, I have structured my presentation into 5 parts. And I would like to start with the introduction, inviting all of you to a journey throughout the last 25 years. What happened in the last 25 years? So I'm starting with 1995. This was the era when we introduced hypertext, and we were very happy that we could hyperlink documents. 5 years later, we moved to multimedia, and we were able to hyperlink media. 5 years later again, we entered the era of social media, and people started to network. Again, 5 years later, we are now in 2010, we came to social media part 2, where companies started to establish their networks. And 5 years later again, cyber-physical media came up, and cyber-physical media enabled systems to interconnect and to communicate with each other. Now, what is happening in the next year, 2020? It's always difficult to predict the future. However, what we see is we are entering into an era of smart networking. 5G is coming, and also artificial intelligence is being implemented in many of our approaches, such as machine learning, pattern recognition. What is very interesting is the introduction of so-called smart contracts, but also engineering smart systems and collaborative robotics. So, as you know, Industry 4.0 has been established in 2010, and the term is a play on words consisting of 3 elements. Industry, of course, is dedicated to the industry. Second, .o references the internet technology and intends to create the association with Web 1.0, Web 2.0, and Web 3.0. By the way, Web 4.0 is not on the market yet. Therefore, the 4 stands for the 4th industrial revolution, and this is clearly aiming at cyber-physical systems. Now, Industry 4.0 in industrial terms means that we are going to increase our value chains, and this is happening through the establishment of our platform, Industry 4.0. You see the organization chart here, and this platform consists of 3 pillars. In the middle, we have the strategy. Then on the left side, we have the operation, and on the right side, we have the implementation. Now, what about the organization and the research strategy? Professor Kagemann has mentioned before that various strategic research projects have been established. Industry 4.0 was the first one, and the outcome was the establishment of the platform Industry 4.0. Then the strategic project number 2 has been established with respect to smart service Welt, and the 3rd strategic project is now going for autonomous systems. And there also the platform artificial intelligence has been established. By the way, when I'm talking about platform, this means that we are establishing communities of motivated and interested partners coming from the industry, coming from scientific community, coming from the trade unions, and also, of course, coming from our political departments. So, as you know, Industry 4.0 has created a vision for 2030, and this vision consists of 3 important goals: autonomy, interoperability, and sustainability. You find more by accessing the document, which you can easily access through the QR code. So, in fact, what is important here is that we are operating in 6 working groups: reference architectures, standardization and norms, technology and application scenarios, security of network systems, legal framework, work, education and training, as well as digital business models in Industry 4.0. We are creating recommendations. We are supporting small and medium-sized enterprise mobilization and also international cooperations. And now the strategic approaches. There are 2 important items which I would like to present here. First is the memorandum for a more agile and flexible innovation system in Germany, and the creation of 4 strategic research fields. First, to the memorandum. The memorandum, which we created, aims at making the German innovation system more flexible and more agile. The goals are speeding up, more flexibility, more agility, robustness, cultural change, very important, user orientation, and also new working methods. So we are creating new spaces, not only for manufacturing, new formats, in particular for interdisciplinary collaboration, and we are also establishing new indicators which are criteria to evaluate applied research. And this is the document which you can also access very easily. And the good news is it's also available in English. Unfortunately, not in Japanese. So, we also created 3 important thematic fields for research. The first one is called economical and value creation scenarios. Second one is prospective technological trends, methodologies and tools, and work and society. And by the way, these thematic fields are handed over to our government for establishing new research funding programs. And these are not only projects, these are complete programs. So, what about the digital transformation? Now, you know, I'm a mechanical engineer, and in mechanical engineering, we always aimed at improving the value-added chains based on functional integration. So we moved from mechanics to mechatronics to adaptronics. Now we are going for cyber-physical systems, and this is creating a new value with respect to condition monitoring, systems and structural health monitoring, remote diagnosis and control, as well as tracking and tracing. And these approaches are then applied in various application areas like smart plant, smart manufacturing, smart factory. Of course, for us is the most important one, but the others are also very important. Smart city, this has a direct impact on the society. Smart grid, smart products, smart logistics, as well as smart home. And you can also name further application areas like smart health, for instance. So, and of course, the smart factory is one of our most important target. And here in my university at Darmstadt, we have established in the meantime 2 so-called learning factories where we have implemented these methods and tools. But also the city of Darmstadt has been awarded the prize of so-called Digitalstadt, Darmstadt. That means Darmstadt has received the award for developing Darmstadt as a smart city. So, now what is our strategy to transfer Industry 4.0 to the industry? In the university, we have a couple of research and development labs where we are performing fundamental research as well as applied search. If we have some research results, then we are transferring the research results into our demonstration and learning centers. And these demonstration and learning centers are open not only for our students, but also for those from industry who are interested in getting a further education, a further training, a further qualification. Therefore, we have also established a competence and transfer center, in particular for enabling the employees of the small and medium-sized enterprises to get this knowledge. And we are also providing our centers for prototyping and as a testbed. So, thanks to the funding which we receive from the government, but also from the industry, here, for instance, is named VDMA, which is the Association of the German Mechanical and Plant Industry, as well as our Ministry for Economic Affairs and Energy. This ministry, Mr. Hess was just giving his presentation, has established in the meantime 26 competence centers for Industry 4.0 all over Germany to enable the small and medium-sized industry to adopt this technology. So, and a really hot topic in this context is OPC UA, the Open Platform Communication Unified Architecture, which is promoted by VDMA. And in fact, the idea is to establish OPC UA as a standard, as a worldwide standard, and for enabling the various systems from the various branches to communicate with each other, we are developing the so-called companion standards. And here is a snapshot of the various industrial units from mechanical engineering at VDMA, indicating in blue color OPC UA. CS means companion standards which are released. The orange ones, they are in progress, and the gray ones, here the awareness has been created, and we are establishing in these branches the development groups. So you see that there is a very wide and broad acceptance of this technology in the industry, in particular in the small and medium-sized industry. So my conclusions: the digital transformation is a key success factor for industry to gain increasing and sustainable competitiveness. Industry 4.0 is the key initiative of the German high-tech strategy. It's supported by the government and implemented by the industry. The key strategy is the creation of new innovation for smart systems, such as products, production systems, logistics, grids, and further systems based on the integration of internet-based communication and embedded control software to ensure sustainability and environmental soundness. The current situation is that the political level has created strong awareness, industry has organized, and the society is quite aware that, in particular, the working environment is changing. So the digital transformation based on Industry 4.0 enables an agile and flexible innovation system and strengthens industrial competitiveness. So I would like to end with a phrase from a German philosopher, Lichtenberg. I cannot say whether things will get better if we change. What I can say is that we must change if things are to get better. Thank you very much. Oops.
ありがとうございました。